Hi folks, a bit of a teardown and repair video today. So what you see in front of you is a Thin Client made by HP. That's my laptop, ignore that. And what Thin Clients are basically just remote access terminals. So they're a computer inside, low amount of processor and RAM, but they have a network interface card built in, and a bunch of I/O. So you got sound, USB, keyboard, serial, parallel, VGA, and more USB and sound on the front. And you set these up to connect to like a main server that actually runs applications that users are running. So say you would stick this maybe at a a reception desk or something like that, and this would just sit there, connect it to the monitor, and a main server somewhere would be sending basically the images and things like that, and be processing all the user inputs sent by this. So if you do this, you can reduce power consumption for all of your workstations, because if you had 100 workstations all running MS Word, you'd be better off getting 100 of these and maybe 2 or 3 big servers rather than 100 workstations. You'd save a lot of power, and administration gets easier. But anyways, the reason I'm interested in these is because they're essentially a very cheap but rather powerful, all things considered, machine that runs on low power. So this thing, I believe, has a 400 or 500 megahertz processor, I think 64 megs of RAM. But the crucial thing is that I bought it for $16, and there's lots more similar to this on eBay. Actually, for instance, this one is an older one, but I got this for I think $12. This only has a 200 megahertz processor. But they're a great alternative to things like Raspberry Pis, if you can spare a little bit of the power consumption. The Raspberry Pi, I think, is like 3 to 5 watts, I'm remembering. This is more like 15. The other one is, I think it was 7 or 8 watts, just sitting idle. But the benefit is that they have lots of real USB ports. They have real serial. They can do net boot, all that kind of good stuff that you'd expect from a real PC, yet cost less than a Raspberry Pi shipped to your house. So that's why I like them. This one here is destined to go inside of my car, for a car PC type thing. But the problem is, I bought it. Let me plug it in and show you what it does. Just plugging in my monitor here, plugging in my high-tech power lead. Just clipped into my lab power supply. So plug this sucker in, hit the button, and the button turns on, no problem. But you can read right there, no input signal, and this can sit here for as long as I want, and it doesn't do anything. It is drawing power. It's drawing about, I don't know, 1.5 amps here at 12 volts. So I'm not sure what's going on, but I figured I'd make this a bit of a teardown and hopefully a repair video. Maybe there's a bad capacitor somewhere in there that's gumming up the works. This was built in 2006, so it is within the range of the bad caps kind of era, although it's a bit late for that. But anyways, so yeah, let's start ripping this apart and see what we can find. They're basically a normal PC inside. But it might be interesting to see how they've integrated all this stuff into basically a very cheap, low-power machine, and we can see how they've implemented the storage. Because I believe what they have in here is a module that pretends to be IDE, parallel ATA, but is actually flash. That might be interesting to check out. So let's take the cover off. And here we are in the Teardown Bench. Here's the information. It's a bit confusing because you've got it says here HP Compact t5720 AMD and a bunch of stuff. Then there's a model number of HSTNC-001L-TC. I'm not sure exactly what's going on there, but I'm pretty sure this is the real model number because I see a HP Compact T5000 here and a T5720. So I bet that's the real model number. But anyways, yeah, manufactured November 2006. It's interesting, see this tab here and this tab here? Well, only this one had a screw on it, so I'm wondering if someone's already had some hacking in here, but anyways, you just undo the screws that are there and pull it up. And that's it. It's also interesting. A little speaker. Okay, we've got a pretty nice heat pipe setup. That looks like the CPU in a socket down there. See the little lever for the ZIF socket. I assume this is the GPU. We've got some heat pipes going out. One nice thing about all of these systems is that they're fanless, so you don't have to worry about noise. And this is very interesting. PCI card, so we can expand this. Oh, this is a RAM slot. Is it? Maybe that's why it's not booting up, because someone nicked the RAM out of it. Let me get some RAM and stick it in there and see if it works. Alright, so I threw a half gig of RAM in there. Let's see what happens. Oh, let's turn on the screen. Power on. Oh, I saw it. Oh, well, there you have it. See if it boots. Oh yeah. Oh no, didn't boot. I think, yeah, I'm pretty sure someone's nicked the disk as well, which I'm kind of annoyed, but I'm pretty sure this is a regular IDE. But I don't really mind, because I wasn't going to use that to boot anyways. I was going to use a flash disk. So in here I've got a Linux system, so let's see if I can boot this. And then we'll go and finish our teardown. Alright, keyboard has been hooked up. Let's see, I think it might have been F12. No, F10. Oh, password. Uh-oh. This could be annoying, folks. Let's try HP. Invalid password. Admin. Password. This is annoying. Let me do some research online real quick. Alright. No luck there with finding a default password, because apparently the default password is empty, unlike that Wise terminal down there, which has a default password of something or other, which you can find by Googling the part number. There's actually a regular IDE connection, so I could, in theory, hook up a laptop drive, no problem. So I've got this handy dandy set of adapters, you know, IDE connector to regular IDE desktop to laptop style, and then another one at the end. So I think the pinouts will work. So if I want, I can put a laptop drive in there. But for now, let's just continue with the teardown. In order to get past the BIOS password, I'll do the classic thing, which is rip out the BIOS battery and just wait a while. And while I'm waiting, I'll do the teardown. I don't see any BIOS clear switch anywhere, so we'll just have to do it the old-fashioned way. Alright, it's drawing a little bit more power now with the RAM, maybe 1.8 watts, no, it's not watts, 1.8 amps. Anyways, power this off, continue. Nice heat pipe assemblies. They're just held in by some screws. Oop, this one's a bit more temperamental. Did one of the screws not release? Alright, we've released that. Similar deal. Let me clean some of this out, take the board out, and we can start looking at things. Well, this is quite nice. You take out one screw there, and this entire tray lifts out. I didn't even need to remove the heat sinks, because they just would have lifted out along with this board. Of course, I wanted to see what was under them, so no worries there. Nothing interesting at all on here. It's just some metal chassis. I've got mounting hardware, of course, that actually goes into these nice standoffs here. You can also mount it from the top There's holes on the PCBs for the screws to go straight through here, so you get a nice solid hold there. So I've already taken off the screws that hold this board to that little tray here. So, oh, I see. Never mind. Okay, it's slightly different than what I thought. You have to remove these and also these screws to remove it, but no matter. Let's get rid of the RAM I added. Alright, so let's start looking at the main chips here. So the main CPU is an AMD Geode, ANXL 1500 FG C3F, just in a regular socket, so you can put other, say, Athlon in this thing here. And so in theory I could take my zombie PC up there and transplant it into this, but I'm not gonna. This thing here is the SIS741CX, basically integrated chipset. It has the memory controller, it does IDE, it does the integrated graphics. I think its maximum resolution is only 1024 by 768. But I was just looking around and I found the marketing documentation for this thing. You know, just the regular stuff. See, here's kind of the basic architecture. See, it has the built-in video and RAM controller. But if you look down here, performance comparisons, right? So you're looking here, okay, the first one is a 3D Mark 2001 SE. The second one, Quake 3. Nice. I like SIS now. That's how you compare chipsets. And of course, this SIS 963 is a companion of this guy. You know, it handles things like the PCI and probably USB. I kind of looked at where the traces were going, and it seems to come up right under there. So I'm betting this is doing USB. As for other things here, so if we trace over here, this is clearly like the BIOS area. So this is probably the BIOS for the system. Probably the timekeeper watch crystal here. A 25 megahertz clock, that's probably generating the system clock. Let's see, up here I noticed that I do have a little header. I'm assuming that's the BIOS clear, so I'll just, oops, if I can do this, there we go. I'll just put a little jumper on there for now. This down here is a VT6107 Ethernet controller. There's the Ethernet right there. Makes sense. This guy, I have no idea what it is. It's a ICS 6315259. No idea what that does. This one here, SMSC, is a Super I/O controller. Here's kind of information. You know, it does the whole ACP thing. It has game port support, I suppose. If I wanted to, I guess I could solder on a game port. ISA, MIDI, floppy disk, keyboard, serial, infrared, you know, all that kind of stuff. Some more hardware monitoring things. Kind of normal. This over here is an ALC 655. That's the AC97 audio that a lot of these systems have. I guess that's wired up directly to these audio jacks up here. That's about it for this little corner. Heading a bit further north here, start getting into the power supply section. So these are a bunch of MOSFETs. These two are MOSFETs, you know, a couple inductors. Not too interesting. Over here we have the classic MAX 3243, you know, RS-232 driver. There's your RS-232 port. This is a 7407, you know, buffer. And that's about it for this area of the board. I've missed these two crystals here. One's a 14.318 and the other one is 24.576 megahertz. Yeah, one of those will be the system clock. This one here is probably not the system clock. It's probably driving the Ethernet. This one's probably the audio clock, and maybe this one is the system clock just by its proximity to things. Now on this side of the board, we've got a LM358 op-amp here, which is kind of odd, but fair enough, I suppose. We've got this interesting device, APL1581. That's a linear voltage regulator, but high efficiency, with an output of between 1.25 and 2.55 volts. You can kind of see here. especially for microprocessor supplies and things like that. And the way it gets a low dropout is apparently it breaks out this V control here, which you give a voltage higher than V in, and it somehow is able to use an NPN transistor there in order to run the device a bit more efficiently. I'm not sure, I haven't read much into that, but it's definitely an interesting read so far with a look. So I will admit I'm a little bit confused about this device, because the core of this CPU here is 1 volt, which is below the 1.25 volts minimum that the datasheet for this thing suggests. So I'm not sure what's going on there. I don't think it's supplying the IDE, because that runs at 5 volts, definitely not the USB, again 5 volts. Maybe it's powering this stuff, but it is a fairly high power device. The maximum rated current is 5 amps, and the power is... it doesn't say here. Well, it's one of these big chunky packages, so it's going to be quite a bit. And over here, all by itself in the corner, is an APL 5331 voltage regulator. Does 300 milliamps, and it's pretty clear that it's going right to the RAM here. I see the trace going right in there. Alright, now we're looking at the bottom side of the board. This is underneath all that power circuitry. So this one here is a Fairchild 52040 MTC. This is a PWM controller made especially for these types of AMD Duron or Athlon processors. A couple power diodes, a classic 78M05 voltage regulator. This is an intercell something or other. What was it? Can't read it. 6227CAZ. This is a dual PWM controller, specifically designed for mobile applications. This isn't quite mobile, but it's low power, so if that makes sense. And this APW7037B is a synchronous buck PWM controller by, who was it by? Anpec Electronics Corporation. Never heard of them, but I guess they do stuff like that. Cool. And the last two significant bits of silicon on the board are this SSM 2211 low distortion audio amp from Analog Devices, and this E2 Prom from Atmel over here. Not sure what that would be for, but I guess it would be for storing BIOS configuration or something like that for the NVRAM. And that's about it. That is everything other than a few random little transistors laying around. Now let's put all this thing back together and see if it still works. Apply some new thermal paste here. And I just discovered a pretty nice touch. All the screws have this thread lock on them. It will definitely come in handy when this thing goes in my car and gets bounced around all day. Nice touch, even though it's not a mobile application. Thermal paste has been applied. Alright, so everything's back together. I've replaced the RAM with a 256 because I don't think I'll need 512 for this particular application. I noticed one thing that see these heat sinks or I guess radiators move around quite a bit because there's nothing holding them on this side. I might want to like secure these in some way because I don't like the idea of these things bouncing around as my car goes over bumps. I might have to print something on my printer there to hold these, maybe a bracket that clips around the end of that heat pipe, but I'll figure something out. Anyways, moment of truth. Let's flip the power on. Why is it drawing a bit more power at idle? Oh, this thing is on. That's right, because it's glow in the dark. Okay, let's hit the power button. See what happens. No fire, I hope. There we go. So let's hit setup. And the password's gone. Yes. Just goes to show you how useless those BIOS passwords are. Take someone, just a couple minutes to get rid of the battery or find the, the clear jumper. Not very useful unless you have a hardware lock on your case. But anyways, there you go. AMD Geode NX 1500, as we know, running at 1 GHz. Asset tag. There we go. That's my asset tag. Standard CMOS features. Nope, it's not 2003. It never was 2003 while this thing has existed. Why does it reset to 2003? Not, 1980 or whatever. Anyways, whatever. Anything else in here? So as you can see, this is a pretty standard PC. That other one down there had a very, very minimal BIOS. Let's see, first boot is USB, that's what I want. ATA flash, well, you don't have any ATA flash because someone nicked it and didn't tell me. Lame. Security option. Integrated peripherals, yeah. Power management. Oh, I probably want to change this to off, because I don't want it to turn back on if I turn off my car before it has a chance to shut down. Let's see. Save and exit. Yes. Now boot something better than XP embedded. Aww. Missing operating system. Oh, I'm using the wrong flash disk. Sometimes it's difficult being me. This is the one I want. That one just contains a bunch of... What does that contain? I don't even remember. Oh yeah, that thing was containing a bunch of 3D printing stuff, models and things. Not that it really matters to you, but I'm filling in time, covering for my mistake. This is a tiny core Linux, by the way. There it is. Okay, cool. So it has no problems booting from USB. Blink, blink, blink. It's a bit slow, though. It's not loading much. Wow, that was a quick boot. No LSPCI. Well, whatever. It works. So I'll conclude this here. Oh wait, no, never mind. I won't conclude this here. I want to try making the drive work. Be right back. Let me wire that up. So as my test subject, I've got a very dead laptop drive that I've ripped the label off of. Because I don't remember why, but it's been without the label for a long time, and it's, really dead. Let me spin it up to show you how dead. Oh, it's actually staying spun up now. That's weird. It hasn't done that before. It usually just spins up and back down. Well, anyways, it should at least be detectable, and if it explodes, well, no big deal. So I've hooked up one end of that adapter. See, there's nothing on the other end. Oh, where's the other end? There's the other end. And hooked up the power, and I'm seeing that I do have 5-ish volts, so it probably won't explode anything if I hook it up. Here at Spagamoto Enterprises, we make sure to only use the highest quality adapters to make sure that there's no data loss or system instability. Anyways, let's push the button. Nothing's happened. Oh, wait. Wait. I see blinkage. Oh, it's not happy with me. Oh, it's my power supply, isn't it? Oh wait, no, there it goes. Maybe not quite. Alright, so something is weird. It's anyone that knows IDE connections better, could they tell me what I did wrong? Can you hook up an adapter like this? I thought you could. I guess not. Let me troubleshoot it a little bit more and then we can check things out. Uh-oh, I guess I shouldn't have done that. This thing isn't happy with me. I get nothing on the screen anymore. Well, remember what I said about not exploding? Well, that was a damn lie, apparently. Because we're drawing power, but nothing's really happening. It's getting slightly warm as it did before. Crap. Let me poke around a little bit more and see if I can't revive this thing. Phew, wouldn't you know it, it was my screen that had freaked out. I don't know, it locked up, but it would no longer recognize signals, so I power cycled the darn monitor, and it works again, so I might try hooking the disc back up again and see what happens. I think I'd learned my lesson. Cut 2. Massive fire. Well, surprise, surprise. No fire. Oh, helps if I turn on power supply. Contact. Come on, screen, don't let me down. Power cycle you. Well, I don't hear the damn thing spinning up, but... Hello? Ooh. That, I think the screen is on its way out. Yeah, I didn't find anything over there. Let me try powering the hard disk separately. I don't think it's liking this jury-rigged thing. Uh-oh, folks. That doesn't look good. Remember when I said I wouldn't learn my lesson? Anyways, I'm not sure what's going on here. This thing still does work. I see it boot from this USB thing. I see the activity light blink in a way that looks like it's booting. I'm gonna get a backup monitor. I don't trust this thing anymore. Damn, I keep screwing myself up with this stupid monitor. See, because look, if I plug it in, my nice trash-picked, beautiful Samsung SyncMaster 214 works fine. I saved you out of the garbage heap back in college. I could put you back. It's such a perfect size. Okay, well, let's put the drive back in and see if it works for real this time. Sounds healthy, doesn't it? Well, maybe I should stop throwing dead drives at this thing. Ooh, that's not a nice sound. That thing had a bad head crash, and I've had the cover off of that several times. Oh, wait. Ah, there it goes. Alright, let's see. Oh, look, it detected it. So it looks like all you need to hook up an IDE, you know, let's turn this thing off before it really explodes. But all you need to hook up one of these drives is two laptop to, desktop IDE connectors. Just put them at the end of an IDE cable, hook up power somehow, you know, with the adapters that came with the adapters. Meta adapter, adapterception. Anyways, hook up power and you should be good. So I think I'm gonna, stick a 40 gig drive or something in here, just to have a nice music collection on my car, and then I guess I'll have a USB flash disk for the actual operating system. I think. Haven't decided yet. This thing is going to see very little I/O because the operating system is going to be running is probably going to be tiny core, bare minimum of processes going, just enough to show me some information on the car in a graphical interface. But anyways, that's, I think, for another day. I think this video is now getting massively long and is probably quite boring, so I'm going to end it here. Thanks for watching, and hope you learned something at least. Oh, and by the way, not all thin clients, not all thin clients are nice and expandable like this. For instance, this one here, everything is soldered in. You can't upgrade this at all, except through the USB, of course. And more annoyingly, this thing does have an internal IDE connector, but it's with a pain in the butt custom connector, which I think I found on DigiKey somewhere, where I can buy and make my own adapter. But it's going to be a bit of a pain. Fortunately, I do have the original flash disk that came with this thing. Unfortunately, I can't write it because if you boot this thing from USB, it freaking disables the onboard IDE controller, so no operating system can access it. Like, I can boot Linux and I can poke around all I want, but I can't get it to detect the damn drive. So I can't even flash Linux on the drive, which isn't a huge deal, but there's a bug in the BIOS where if you boot from USB, not only does it disable the IDE controller, the bandwidth, or sorry, the bit rate of the USB while it's booting is abysmal, so it takes several minutes to load a tiny kernel and start booting. But once it boots, it's fine. But I don't plan on using this in my car. I haven't actually decided on what to do with this one, but it runs on 6 watts, so lots of applications there. Anyways, thanks for watching. See ya. You know what's bizarre, actually? So I've hooked up this monitor back to my zombie PC, and it's showing about a similar amount of light. But maybe you recognize this pattern. It was showing in black and white when it was hooked up to the Thin Client. That is bizarre. So apparently this thing survived in the frame buffer of this LCD for several power off and power on cycles. That's crazy. I really don't want to have to fix this thing again. Oh man. Alright. It was a bad cap last time and I replaced it with a cap that I found on some random PCB somewhere, so not too surprising that it failed, but it did last like 3 years like that, so oh well. I'm telling you, the fewer crap Exion caps I have in my life, the happier I'll be. Lame.